Do you know the tools and techniques to perform software assessment? Stick around because that's the topic.
You're watching IT Pro TV.
Hello, ladies and gentlemen. We are continuing our discussion in CySA Plus, and we're going to go ahead and start out. I need to know, what is static analysis, Dan?
Static analysis, well, is the topic du jour today. That's right, the soup of the day.
That's right.
Sounds good. I'll have that. Static analysis is the idea that we are going to look at the code of an application and see if we can't find vulnerabilities or weaknesses therein. Therefore, and then fix them before it becomes production, before it gets out there in the wild. That's what we'd like to do. But it doesn't always happen before it goes out. Unfortunately, that is not always the case. Sometimes we're doing static analysis of code after it's already been pushed. But what are you going to do? Better late than never, right? The whole idea is to find any weaknesses or vulnerabilities that may be exploited against the software and systems and applications that we use in our environments. So static analysis, what does that mean? So static analysis means that I'm either going to use some sort of automation or my human senses to parse through that code, find those vulnerabilities. Now, we are going to rely heavily on that automation because it could be a daunting task depending on the application, how many lines of code there are, and how many people are available to manually review that. So let's start there with that automation. And now I've got a great website pulled up for us here that will help us out with this and give us a list from the good old NIST. I'm going to show you that URL just in case you're curious. It seems like it's got some sort of thing to do with yoga. This looks like samate, not namaste. But samate.nist.gov. And this is the source code security analyzers page. And in here is a wealth of knowledge. First it kind of tells you what this is all about, like the purpose. The purpose, there it is right there. Let me zoom in. Examine source code to detect and report weaknesses that can lead to security vulnerabilities. That's exactly what we're looking for. Hey, thank you so much, NIST. It's like you read our minds. And then down here is where the real gold lies, because there is a laundry list of software analyzers that you could use depending on the language that you're using and what it is you're looking for. So here we've got some that languages that it assesses are in Bash, C, we see Java, Ruby on Rails. Here's one, the CAST Application Intelligence Platform does quite a bit of lifting. I mean, that is just a list of different programs that it can analyze and look for issues that could then become vulnerabilities, that could then become exploitation. So depending on your environment, you're going to look through these, find some of those software analyzers that will work for you and what you are actually working with and the technologies that you employ, and then find the one that works best for you and your team. So that's going to be a great resource right here. Even kind of gives you a rundown over here on the right-hand side on more specifics on what it looks for and how it looks for them. So good stuff there. Wanted to make you aware of that. I'll make sure to make that in the learner resources. I'd like to keep those available for you. So let's move on to, now that we understand automation, right? Because that's really where we're going to lean heavily on. But we will need to do manual assessment as well, right? It's not something we're going to get away with not doing. So a couple things we need to know about that. Typically, you'll hear this is called code review or peer review. And this is the idea that I'm going to get people that know about this together, and we're going to look at these things. We're going to sift through the data and see if we can't find those exploits and weaknesses. Doing that automation, except it's not automated, it's the manual way. Types of testing other than peer review is UAT, or user acceptance testing. This is an interesting form of testing. It's kind of like a beta test, where I'm going to take a group of people. I'm going to tell them, these are the type of tests I would like you to run. Basically, work with this and see if you can't find any flaws or weirdness or, God forbid, vulnerabilities in that way. And then they'll report back to the team that is developing it, and then they'll make the changes as necessary as it has been reported. Last one is security regression testing. Bang, love that one. Because the idea of, what's the old philosopher that said, you never step in the same river twice, right? The water's always moving, it's always changing the environment. Well, code is very much the same way. A lot of times it's being updated or patched, and that code is changing. because the code changes in any way, maybe the security that we have implemented into that program or that application is now broken, or it doesn't work right, or it's working, but now it's working differently. We need to find that out. And that's what regression testing is all about. We need to figure out if any of the changes that we are going to make are going to break things. And if so, we'll need to create workarounds for that, retest it again, and make sure that everything's working as we need it to work before we push it out to production. And then we can give you that patch. Then we can give you that update, and everything will be great.
Sounds like you could almost, Dan, and roll that into like a secure coding best practice as
Yeah.
well, especially with all those buzzwords like continual integration, continual development, iterative, I guess coding practices. Things can change daily, nightly, if you will, weekly. We need to stay up on the secure coding practices as well. Now, you've mentioned static analysis, and I'm looking at the code. Now, the next one here, I would say is probably kind of like the opposite of that, and this is dynamic analysis. So I'm thinking this is somewhere in the time of, well, runtime, right?
Yeah, that's exactly right. This is not the actual code file itself. This is the application. It's compiled, it's running, it's doing its thing. And we want to take a look at it. We want to start to analyze how that works. And that's why they call it dynamic analysis, because things are changing. There are moving parts at this point, and that could adjust certain things in a way that you didn't anticipate for. So we need to start to look for those types of things. Let's jump into my computer. I got a Windows machine up and running, and I've got an application. This is a vulnerable server that I found on the internet, on the interwebs, for doing this type of thing. So it is purposely vulnerable. It's up, it's running, it's waiting for client connections. Awesome. It's not really important. What's important is I've got this thing over here called the Immunity Debugger right here. Not the only game in town, but it's one I really enjoy. I'm gonna double click that. And when it starts, I see I got these 4 panes, and what's going on? Yes, very small. I understand. I'll do the zooming as necessary. What I'm going to do is I'm going to go over here into the top left-hand corner. I want to go to File and click Attach. And there I see the vulnerable server process running on the machine. Awesome. Now what I can do is I'll zoom out a little bit, and I will click Attach. Once I do that, you'll notice that all this information propagates. This is the assembly code that is actually running in the machine right now. That I am dynamically looking at that. Now, as soon as it runs, you'll notice it is paused. So once I hit the play button, it is now running, and I can actually, I'll jump over here, get in a terminal, NC, was it NV 10.10.10, I think that was 156 on that box, and it's port 9999. And you see I've made a connection. It is running normally. And you can see over here that I'm getting information about that, right? And I can look at things like the registers, like here's, oh, of course it's going to go away on me. It's probably doing something different now in the background. But I could follow those. I can make breakpoints. I could see what's happening in each one of the stacks, in each one of the registers, look at that information, and then even maybe start to do some stuff we're going to talk about later, which is fuzzing, and start to build an exploit out if I find a vulnerable input, right? So that is what's called a debugger, and that's what it does. It's meant for us to help, or meant to help us do that dynamic analysis. So good stuff. Like I said, not the only game in town, but that's the one I like. It works really well. So pick your poison on that. A couple other things that we need to do when we're doing dynamic testing, which are stress testings, or at least we need to know about them. Not everybody's got that risk appetite, but stress testing is the idea that I'm going to try to overwhelm the system in some way and see where its breaking point is. Where can I make it fail? A couple of ways in which we can do this. We can send like overwhelming read writes to file or memory. We can overutilize the CPU and see how that handles that, or at least attempt to. That's what we're going to do. We're going to attempt to do these things. We can overwhelm the network protocol. So like I've got a network server right here. What happens if I send it so many requests that maybe it can't handle all that? Where's that breaking point? Let's find that out. So that's going to be really good for a dynamic assessment. Basically just trying to figure out how this machine runs and what it can do, and if we can eventually break the thing.
All right. So one of the things that we also have to do, one of the techniques that you and I have kind of talked about, maybe you can help our viewers out there, is reverse engineering.
Yeah.
Right. So you can use something like a dynamic, analysis, right, to maybe use that as a first stage of reverse engineering the code. Right.
Yeah, that's exactly right. I can see it run. That can be definitely a part of reverse engineering. I'm definitely seeing the assembly language that's happening here, the instructions that are being run through my debugger. But we also have a disassembler. And disassemblers can look at compiled programs and try to figure out the code that makes it up. And in that way, we can learn more about it and try to discover security vulnerabilities. And that's the whole idea. Now, this is always a double-edged sword. There are threat actors out there doing the exact same tools and techniques that we are talking about right now so that they can discover those vulnerabilities in order to exploit them. We're trying to discover them in order to secure against them, right? So let me just pop that down. I'll pop that down as well. And let me open Ghidra. And I've run that same vulnerable server into Ghidra. I found the main function, and I'm looking at it, and I can see that Ghidra has attempted to actually recompile or recreate the source code that is running that program. Okay, and I'm getting usage. I see mem copies and printfs. So it's obvious to anybody that's into coding. This is probably some sort of C language that it's been built in, which I know for a fact it is built in C, so good on Ghidra. It did come out perfectly, and there's some tricks that you can do to make it more accurate. But for the most part, I'm seeing a pretty good representation of what that program is meant to do. I can make those adjustments and make this look a whole lot nicer, but that's what this is meant to do. Ghidra was the NSA's tool that they were using that they now freely distribute, or at least, I don't know if they use this anymore. They probably got a better, bigger, better, faster kind of thing going on, but you can now go download this and work with that. IDA Pro is very popular. It also costs money, so just be aware of that, but it works really well, and you'll see that in a lot of shops that do this type of activity because of its really good functionality. I didn't have the money for that, so here we are with Ghidra.
Dan, I'm semi-familiar with this next technique about throwing random information at your application and saying, all right, what's happening, good or bad? And that's a concept known as fuzzing. Can you elaborate a little bit more on that concept?
Yeah, let's dive into fuzzing. It's a great topic because this will be one of the techniques, if not the techniques, that you use to try to find those areas in which your application may actually break. What we're doing with fuzzing is kind of what Wes alluded to, which we're gonna take that shotgun approach. We're gonna throw some stuff at it and see how it handles it. How does my application handle when it's looking for, maybe I've got like an input box that says, please type in your username, and I give it a bunch of numbers, and I give it 10,000 numbers. Most usernames are not 10,000 numbers. I'm going to go out on a limb and say that with relative confidence. Did the programmer that made this application and programmed that input, did they anticipate that to happen? If they didn't, well, it might crash the program. Maybe they did anticipate it and it gracefully handles that and just defaults to say, hey, that's not what I'm looking for, buddy. Try again, right? That's what we want. But if we find that it crashes the program, we might have an input that we could use to actually develop an exploit. That could be a vulnerability. And that's what we're doing with fuzzing. We're trying to find those spots. So the three normal types of fuzzing, or general types of fuzzing that you'll see, is application UI, protocol, and file format, okay? With application UI, you have an application, right? It's got input from the user. We're going to try to exploit that and see if we can't throw some random bits at it and see what happens. I've got an application right here. It's a web application, but an application nonetheless. And it's the good old DVWA. It comes in handy from time to time. And it's got an input area, right? Taking stuff from the user. I'll type in something. I'll hit OK. Cool. What happens if I type in A? Submit. Well, it doesn't do anything. It gracefully handled that. Excellent. But this kind of leads me to believe that there might be a SQL injection vulnerability in this input in some way, shape, or form. The cool thing is I've been grabbing all my requests in Burp Suite. And Burp Suite allows us to do some fuzzing. If I go to HTTP history, I should be able to see what I've requested right here. Yes, I know it's small, but we'll go down in here. And I can see right here, here was my GET request, and there was my ID equals A. There's the information I sent it. Well, if I right click and go to intruder, this should light up the intruder tab, which is right here next to proxy. We can go over here, and what I want to look for is the positions tab. And right here, you'll notice we got some stuff that's already highlighted and got some strange characters around them. These are just areas that Burp thinks that maybe you would like to fuzz out. I'm going to clear that out. I'm just going to add the one that I know that I want to go for, which is that A. I'm just going to highlight it and then click add. Once I do that, I've got my spot. I'm going to go to payloads and I'm going to add a payload. I have a file that has some SQL injection payloads that I can use. So I'm going to go down here to payload options and hit load, and then choose my file, which is this burp SQL injection small, and hit open. You'll notice that now populates that list with possible SQL injections, right? From there, I should be good to go. I'll hit the start attack button. It gives me this error, or not error, but warning that, hey, this is the community edition, so there's some throttling happening. You're not going to get that speed and efficiency that you would if you went with that pro model. And that's cool. It's worth the money. But if you're using this community edition, that's totally fine. It'll just take you a little bit longer. And there we go. It's off to the races. We can see that it is processing this. And I can actually start to see the output. I've got a payload here. I've got a payload there. And I can look at the request that was sent. And what's most important is the response. That's what I want to know. Once this is done, which it almost is, I like to sort by length going from highest to lowest. Is it descending? Yeah. And I'll just start with the most because there's probably the most information there. So then I'll go back down to the bottom here. You know what I'll do is I'll make this a little bit bigger. Here we go. This will make this thing easier. And now I can scroll and look for that section where stuff would come through. And here we go. I see it right in here. And in there, not only am I seeing the first name of admin, the surname of admin, which we saw when we sent the one in, it actually returned some information from the database, but also Gordon Brown and Bob Smith and Pablo Picasso. So it dumped the database, which means I have fuzzed out the SQL injection. I can use that successfully and dump the contents of the database with it. So it's very helpful. That's what fuzzing is. Give it all that bits, show me which one works. Shotgun approach. Now let's move into the protocol fuzzing just really quickly, which is basically I've got a protocol, kind of like with that vulnerable server, it had some protocols. I could try to fuzz that out, send it via its protocols, a bunch of information, see if it crashes or not. That's the idea. Then file formats where I create a file and then try to get an application to open that file, but it's going to have all that random stuff in there. Now, typically, a lot of times associated with that file format is dumb and smart fuzzers. With dumb, you have, it's just going to flip random bits and see what happens. Whereas with smart, it has some knowledge of the application that you're working with, and it's going to calculatedly, or more calculated, flip those bits and try to manipulate or mutate some information that is most likely to give the response you're looking for. But there you go, fuzzing and software assessments in a nutshell.
All right, ladies and gentlemen, we got to take a look at a lot of concepts when it comes to software assessment. Remember the difference between dynamic and static analysis. Also remember reverse engineering, fuzzing on more of an umbrella term, but then some of the specifics behind the types of fuzzing techniques that you can use. Now, we've got a lot more concepts to talk about in CySA Plus, but we don't have time in this episode, so we will see you there.
Thank you for watching IT Pro TV.